Hey everyone, welcome this chapter Transport Layer Summary. What did I learn in this module? The first point or topic is Transport Layer. Application layer programs generate data that must be exchanged between source and destination host. The transport layer is responsible for logical communication between applications running on different hosts. The transport layer includes two protocols: Transmission Control Protocol (TCP) and User Datagram Protocol (UDP), tracking individual conversations. At the transport layer, each set of data flowing between a source application and destination application is known as a conversation. It's tracked separately. It's the responsibility of the transport layer to maintain and track these multiple conversations. The next point is segmenting data and reassembling segments. It's the transport layer responsibility to divide the application data into appropriately sized blocks. Depending on the transport layer protocol used, the transport layer blocks are called either segment or datagrams. At header information, the transport layer protocol also adds header information containing binary data organized into several fields to each block of data. The next point is identify the application. The transport layer must be able to separate and manage multiple communication with different transport requirements need. And the last point is conversation multiplexing. Sending some types of data, for example a streaming video, across a network as one complete communication stream can consume all the available bandwidth. This transport layer uses segmentation and multiplexing to enable different communication conversations to be interleaved on the same network. Transport layer protocol specify how the transfer message between hosts and are responsible for managing reliability requirements of a conversation. The transport layer includes the TCP and UDP protocols. TCP provides reliability and flow control using these basic operations. Number and track data segment transmit to a specific host from a specific application. Acknowledge received data. Retransmit any acknowledged data after a certain amount of time. Sequence data that may arrive in wrong order, and send data at an efficient rate that is acceptable by the receiver. In order to maintain the state of a conversation and track the information, TCP must first establish a connection between the sender and the receiver. This is why TCP is known as a connection oriented protocol. UDP is also a connectionless protocol because UDP does not provide reliability or flow control. It does not require an established connection because UDP does not track information sent or received between the client and server. UDP is also known as a stateless protocol. UDP is also known as a best effort delivery protocol because there is no acknowledgement that the data is received at the destination. With UDP, there are no transport layer processes that inform the sender for a successful delivery. UDP is preferable for applications such as voice over IP, acknowledgement and retransmission will slow down delivery and make the voice conversation unacceptable. UDP is also used by request and replay applications where the data is minimal and retransmission can be done quickly. For other applications, it's important that all the data arrives and that it can be processed in its proper sequence. For these types of application, TCP is used as the transport protocol. For example, applications such as database, web browser, and email clients require that all data that is sent arrives at the destination in its original condition. Any missing data could corrupt a communication, making it either incomplete or unreadable. The next topic in this chapter is TCP overview. In addition to supporting the basic functions of data segmentation and reassembly, TCP also provides the following service. Establish a session. TCP is connection-oriented protocol that negotiate and establish a permanent connection or session between source and destination device prior to forwarding any traffic. Through session establishment, the device negotiates the amount of traffic that can be forwarded at a given time, and the communication data between the two can be closely managed. The next point is ensure reliability delivery. For many reasons, it's important for a segment to become corrupted or lost completely, as it's transmitted over the network. TCP ensures that each segment that is sent by the source arrives at the destination. The next point is provide same order delivery because networks may provide multiple routes that can have different transmission rates. Data can arrive in the wrong order. By numbering and sequence the segment, TCP ensures segments are reassembled into the proper order. And the last point is support flow control. Network hosts have limited resources, for example, memory and processing power. When TCP is aware that these resources are overtaxed, it can request that the sending application reduce the rate of data flow. This is done by TCP regulating the amount of data the source transmits. Flow control can prevent the need for retransmission of the data when the resources of the receiving host are overwhelmed. TCP is a stateful protocol, which means it keeps track of the state of the communication session. To track the state of the session, TCP records which information it has sent and which information has been acknowledged. The stateful session begins with the session establishment and ends with the session termination. The theme fields in the TCP header are as follows. The first is source port, a 16-bit field used to identify the source application by port number. The next field, destination port, a 16-bit field used to identify the destination application by port number. The next sequence number, a 32-bit field used for data reassembly purpose. The next field, acknowledgement number, a 32-bit field used to indicate that the data has been received and the next byte expected from the source. The next, header length, a 4-bit field known as a data offset that indicate the length of the TCP segment header. The next reserve, a 6-bit field that is reserved for future use. The next control bits, a 6-bit field that include bit code or flags which indicate the purpose and functions of the TCP segment. Window size, a 16-bit field used to indicate the number of bytes that can be accepted at one time. Checksum, a 16-bit field used for error checking or the segment header and data. And the last segment is urgent, a 16-bit field used to indicate if the contained data is urgent. TCP is a good example of how the different layers of the TCP/IP protocol suite have specific roles. TCP handles all tasks associated with dividing the data stream into segments, providing reliability, controlling data flow, and reorder segments. TCP frees the application from having to manage any of these tasks. HTTP, FTP, SMTP, and Security Shell can simply send the data stream to the transport layer and use the service of TCP. The next point is UDP overview. UDP is a lightweight transport protocol that offers the same data segmentation and reassemble as TCP. but without TCP reliability and flow control. UDP features include the following: data is reconstructed in the order that is received. Any segments that are lost are not resent. There is not session establishment, and the sending is not informed about resource availability. UDP is a stateless protocol, meaning neither the client nor the server tracks the state of the communication session. If reliability is required when using UDP as a transport protocol, it must be handled by the application. The block of communication in UDP are called datagrams or segments. These datagrams are sent as best effort by the transport layer protocol. The UDP header is far simpler than the TCP header because it only has 4 fields and requires 8 bits, for example 64 bits. The 4 fields in the UDP header are as follows: source port, destination port, LAN, and checksum. Checksum field used for error checking of the datagram header and data, and LAN field that indicate the length of the UDP datagram header. Port numbers is the next topic. The TCP and UDP transport layer protocol use port numbers to manage multiple simultaneous conversations. The TCP and UDP header fields identify a source and destination application port number. The source port number is associated with the originating application on the local host, whereas the destination port number is associated with the destination application on the remote host. The source and destination ports are placed within the segment. The segment are then encapsulated within an IP packet. The IP packet contains the IP address of the source and destination. The combination of the source IP address and source port number, or the destination IP address and destination port number, is known as a socket. The socket is used to identify the server and service being requested by the client. The client socket might look like this, with 1099 representing the source port number, 192.168.1.5 double colon 1099. The socket on web server might be 192.178.1.7 double colon 80. Together, these two sockets combine to form a socket pair. In this form, sockets enable multiple processes running on a client to distinguish themselves from each other, and multiple connections to a server process to be distinguished from each other. The IANA is the standard organization responsible for assigning various addressing standards, include the 16 bits port numbers. The 16-bit used to identify the source and destination port numbers provide a range of ports from 0 through 65,535. The IANA has divided the range of numbers into the following three port groups. The first group is well-known ports from 0 to 1023. The next group is registered ports from 1024 to 49,151, and the last group is private and or dynamic ports from 49,152 to 65,535. Unexplained TCP connection can pose a major security threat. They can indicate that something or someone is connected to the local host. Netstat is an important network utility that can be used to verify those connections. Enter the command netstat to list the protocol in use, the local address and port numbers, the foreign address and port numbers, and the connection state. By default, the netstat command will attempt to resolve IP address to domain names and port numbers to well-known applications. The next tab is TCP communication process. The reason that TCP is a better protocol for some applications is because, unlike UDP, it resends drop packets and number of packets to indicate the proper order before delivery. TCP can also help maintain the flow of packets so that device does not become overloaded. Sequence numbers are assigned in the header of each packet to ensure all the segments arrive in proper order to the destination. The sequence number represents the first data bytes of the TCP segment. During session setup as ISN in set, this ISN represents the starting value of the bytes that are transmitted to receiving application. As data is transmitted during the session, the sequence number is increased by the number of bytes that have been transmitted. By data byte tracking enable each segment to be uniquely identified and acknowledged. Missing segments can then be identified. The sec number and ACK number are used together to confirm receipt of the bytes of data contained in the transmitted segments. The sec number identifies the first byte of data in the segment being transmitted. TCP uses the ACK number sent back to the source to indicate the next byte that the receiver expects to receive. This is called expectational acknowledgement. TCP also provides mechanisms for flow control. Flow control is the amount of data that the destination can receive and process reliably. Flow control helps maintain the reliability of TCP transmission by adjusting the rate of data flow between source and destination for a given session. To accomplish this, the TCP header includes a 16-bit field called the window size. The window size determines the number of bytes that can be sent before expecting an acknowledgement. The acknowledgement number is the number of the next expected bytes. The initial window size is agreed upon when the TCP session is established during the three-way handshake. The source device must limit the number of bytes sent to the destination device based on the window size of the destination. Only after the source device receives an acknowledgement that the bytes have been received can it continue sending more data for the session. The MSS is part of the option field in the TCP header that specifies the largest amount of data in bytes that a device can receive in a single TCP segment. The maximum size does not include the TCP header. The maximum size is typically included during the three-way handshake. Never there is congestion, retransmission of lost TCP segment from the source will occur if the retransmission is not properly controlled. The additional retransmission of the TCP segment can make the congestion even worse. To avoid and control congestion, TCP employs several congestion handling mechanisms, timers, and algorithms. And the last tab is UDP communications. UDP does not establish a connection. UDP provides low overhead data transport because it has a small datagram header and not network management traffic. Like segments with TCP, when UDP datagrams are sent to a destination, they often take different paths and arrive in the wrong order. UDP does not track sequence number the way TCP does. Therefore, UDP simply resembles the data in the order that it was received and forward it to the application. Like TCP-based application, UDP-based server applications are assigned well-known or registered port numbers. When these applications or processes are running on a server, they accept the data match with the assigned port number. When UDP receives a datagram destined from one of these ports, it forwards the application data to the appropriate application based on its port number. After a client has selected the source and destination port, the same pair of ports are used in the header of all datagrams in the transaction. For the data returning to the client from the server, the source and destination port number in the datagram header are reserved. Webster reflection question. This model had this model had a lot of information about the transport layer. I never knew so much happened here. Did you? When you were going to website or sending an email, did you think about how it was different than joining a video call? Why is one more reliable? Why did you I will receive every word in an email message, but sometimes you will lose a word on your video call? Now you should have some knowledge about the difference between TCP and UDP. I'm excited to be talking this course and how you are too. Transport layer quiz. Question 1. Match the characteristics of the correct protocols. Flow control is for TCP. Application dependent for a error connection. I need to translate this. Wait a second. That is UDP. Reliable TCP. Sequence number TCP. Efficient delivery UDP. Less overhead UDP. I don't know what is this. I say is UDP. Question 2. Which statement correctly describes data transmission at the transport layer? Retransmission of lost packets is provided by bot? No. Segmentation is provided by the window size field when the TCP protocol is used. A single datagram can include both TCP and UDP header. Both UDP and TCP use port numbers. That is correct. Which three fields are used in a UDP segment header? Source port, checksum, and length. What is the last segment sent to complete the termination process of a TCP session that was initiated by a client? Repeat, what is the last segment sent to complete the termination process of a TCP session that was initiated by the client? The last segment sent to complete the termination process of a TCP session that was initiated by the client. Okay, I need to translate this. Wait a second. I think it's a segment with the fin flag set to 1 from the server. What is a characteristic of a TCP server process? Every application process running on the server has to be configured to use a dynamic port numbers. There can be many ports open simultaneously on a server, one for each active server application. An individual server can have two services assigned to the same port. No. A host running two different applications can have both configured to use the same port number, the same server port. No. Okay, question 6. Network congestion has resulted in the source learning of the loss of TCP segments that were sent to the destination. What is one way to that the TCP protocol address this? Repeat, network congestion has resulted in the source learning of the loss of TCP segments that were sent to the destination. What is one way that the TCP protocol address this? I need to translate this. Wait a second. Okay. The source decreases the amount of data that is transmitted before it receives an acknowledgement from the destination. The source decreases the window size. The destination decreases the window size. Okay, the source decreases the amount of data that it can transmit before it receives an acknowledgement from the destination, which field in the TCP header indicate the status of the three-way handshake process. Okay, I don't remember what is this. I say control bits, window, checksum. Okay. What are two features of protocol used within the TCP/IP protocol stack? Choose to or choose to. Repeat. What are two features of protocol used within the TCP/IP protocol stack? Choose to. Okay, I think is this UDP is used when an application must be delivered as quickly as possible and someone loss of data can be tolerated. And TCP mechanisms retransmit data when an acknowledge is not received from the destination system within a set period of time. Match each description with the corresponding TCP mechanisms. Received by a sender before transmitting more segments in a session. Number of bytes a destination device can accept and process at one time. Used to identify missing segments of data. Method of managing segments of data lost. Match the description to either TCP or UDP. Is connection oriented TCP. Is connectionless UDP. Use acknowledgement TCP. Has a large header TCP. Is suitable for delay intolerant applications. Best effort delivery protocol UDP. What is a characteristic of the UDP protocol? Low overhead. Which two flags in the layer 4 PDU header are set by a client and server to determine a TCP conversation? Choice to sync and ACK. Which field in the TCP header indicates the status of the three-way handshake process? Okay. Okay.